All right, guys, welcome to this page of the notes. And again, what we're doing is we're working on finding LCMs by doing linear factorizations of all of our terms and then keeping each factor the greatest number of times it appears. Let's go ahead and try another one. I give you the monomials, 12a squared b, 15a b c, and 8b cubed c to the fourth. I want to find the LCM, the least common multiple of those three monomials. So here we go. I have 12a squared b. Well, 12 is 3 times 4. But the 4 can be factored into a 2 times 2, which would be a 2 squared. So that means the factorization is 2 squared times 3, and you just keep the variables the way that they are. A squared times b. All right, great. 15a, b, c. Well, 15 is a 3 times 5, and both 3 and 5 are prime, so there's nothing else I can do to them. 3 times 5 times a times b times c. What about 8b cubed c to the fourth? Well, 8 can be split up into 2 times 4. But the 4 can be factored into a 2 times 2, which gives me 2 times 2 times 2, which is 2 cubed. So I'll jump straight to the 2 cubed as the prime factorization of 8. And then I keep my b to the third and my c to the fourth. And my LCM will be each factor the greatest number of times that it appears. Well, 2 shows up twice, 2 squared and 2 cubed. I keep the bigger one, 2 cubed. 3 shows up twice, 3 to the first, 3 to the first. It doesn't matter which one you keep. They're both 3 to the first. I'll keep that one. And the 5 only shows up one time, so I just keep that guy. A shows up twice, a squared and a. I keep the bigger one. Keep the biggest factorization of b, that's b cubed, biggest factorization. All right, there we go. So we write all this stuff down. I got a 2 cubed, I got a 3, I got a 5, I have an a squared, a b cubed, and a c to the fourth. All right, 2 cubed is 8. 8 times 3 is 40. 40 times 3, what do I get? I get 120. A squared, b to the third, c to the fourth. So my LCM, my least common multiple, the least common multiple of these three monomials is 120 a squared, b cubed, c to the fourth. Hey, let's keep going. So slightly more complicated than that is going to be, all right, what if we do slightly bigger polynomials? Instead of finding LCM of the monomial, what if it's a polynomial? Well, it works the exact same way. In section 1 of this chapter, we looked at factoring, and I told you guys that all the factoring we did back in chapter 4 and chapter 5 was all going to come back in this chapter. Throughout the chapter, you're going to need to know how to factor. Hopefully, you've had a chance to brush up on it, kind of refresh and knock the dust off, because we're going to need it here again now as well, right? So what I've got for you is I want you to find the LCM, the least common multiple, of a squared minus 6a plus 9 and a squared plus a minus 12. Well, I take my two polynomials. There's the first one, there's the second one. In order to find the LCM, I need to factor those polynomials, factor them, and then keep each factor the greatest number of times it appears. Well, this is a perfect square trinomial. A squared is a perfect square, 9 is a perfect square, so it just simply factors into an a minus 3 and an a minus 3, which is an a minus 3 squared. This one, a squared, 12 is not a perfect square, so this one's just a general trinomial. I need two numbers that multiply to an a squared. Well, that's the easy bit, it's a and a. I need two numbers that multiply to a negative 12, but sum to a positive 1. Slightly trickier, but still not that bad. A minus 3 and a plus 4 will do it. Now, to find my LCM, I keep each factor the greatest number of times it appears. A minus 3, a minus 3. This one's squared, this one's to the first, so I keep the one that's squared. A plus 4 only shows up once, so I keep it. My LCM then is an a minus 3 squared and an a plus 4. So again, all of that factoring we did way back when in this course in Algebra 2 It's all coming back here. You need it to help you find the least common multiple of polynomials. Let's try a couple on our own. I want you to find the LCM of these two polynomials. Well, here we go. I have a y to the fourth plus 8y cubed plus 15y squared. All right, right away I recognize I can factor out a GCF. Start with the GCF. That's going to pull out a y squared. Actually, y squared, which leaves me with a y squared plus 8y plus 15. Well, I'm not done. I should be able to factor this guy as a general trinomial. I need, let's just do it. So y squared and then my two factors. Y and y, that's the easy bit. Slightly trickier bit, I need two numbers that multiply to 15, sum to a positive 8. Actually, not that tricky. A plus 3 and a plus 5 will get it done. All right, so there we go. Y squared, y plus 3, and y plus 5. That's factorization. I had to do both a GCF and factor a general trinomial. All right, this one, y squared minus 3y minus 40. Well, y squared minus 3y minus 40. Let's see what happens. Well, the easy bit, y and y times y gets you y squared. Slightly trickier bit, I need two numbers that multiply to 40, sum to a negative 3. How about 8 and 5? If I did a negative 8 and a positive 5, right? Minus 8 times 5 is a minus 40. Minus 8 plus 5 is a minus 3. Fantastic. Now, LCM. Okay, the factors that appear, the greatest number of times they show up. Well, y squared only shows up once, so I have to keep it. Y plus 3 only shows up once, I have to keep it. Y plus 5 shows up twice, I only keep one of them. And then the y minus 8. And so here we go, my LCM is y squared times y plus 3 times y plus 5 times y minus 8. The LCM for these two polynomials is this guy. All right, let's try one more here. All right, so 4a squared minus 12a minus 16. I recognize, hey, I can pull a 4 out of all of those guys. So 4a squared minus 12a minus 16. Start by factoring out a 4, which will leave me with an a squared minus 3a minus 4. All right, well, hopefully that'll factor. All right, so a times a gets me a squared. I need two numbers that multiply to a minus 4, sum to a minus 3. How about a negative 4 and a positive 1? Okay, the next one, a cubed minus 9a squared plus 20a. Hey, those guys have a GCF of a. Pull it out. Leaves me with an a squared minus 9a plus 20. All right, well, hopefully this general trinomial will factor pretty easily. Spot you the a and the a. Trickier bit, two numbers that multiply to 20, sum to a minus 9. Actually, that's not too tricky. Negative 4 and a minus 5 will do it. So my LCM, well, I got a 4 and an a. I've got an a minus 4. It shows up twice. You keep one of them. A plus 1, a minus 5. My LCM is going to be 4a, and then it's going to be an a minus 4, an a plus 1, and a minus 5. One quick note about these LCMs, and it's this. Notice all of these guys are multiplied together. Order doesn't matter. If you have the a plus 1 first and the a minus, or if you prefer to put them in order, a minus 5, a minus 4, then the a plus 1. Whatever, it's multiplication. Order doesn't matter as long as you can get that least common multiple. Guys, hopefully that makes sense. Head on over to the next page of the notes. We'll try several more of these together just to make sure you've got it down, and I'll meet you over there.